Okay, so let's have another look at these two graphs here, and we'll look at the first of these examples where we're looking at the two trig functions. Again, if you have a look through, I've got some different coloured dots here, and each of the dots, I guess, I've been able to mark in for different reasons. So the blue dots there are points where either one of the graphs happens to have a y value of 0. In other words, the opposite has an x-intercept, yeah? So clearly, if the red graph here at the origin is 0, well then when we add the two y values together, it's just going to go through wherever the green function is. And so each of those blue points correspond to where one of the functions has an x-intercept. All right, so we know the graph must go through those. The black dots then, they correspond to points where, because the graph has been drawn quite accurately, or very accurately, you can add the y value. So the first of these black points here, well, the y value up here on the red graph is at 2. The y value of the green graph is at -1. If we add them together, 2 plus -1 is 1. So the graph must go through that point there at 1. Similarly, down there at 3 pi on 2, -1 plus -2 is -3. So again, they're points that I can be really confident, or definite about, in fact, that the graph goes through. The green points then are just where the graphs intersect, which means the y values are the same, and in fact, so if I add those two graphs together, the resultant value is going to be twice as big. So if you have a look at there at whatever that is, around pi on 6 maybe, or pi on 8 or something like that, the first of those y points, both graphs go through at about 0.75. So if I multiply that by 2, it's around about 1.5, okay? And you see a couple of green points there where either the graphs intersect, actually the first two where they intersect, the next two where they seem to be about equal distance from the axes, yeah? So the positive value cancels out with the negative value. I'll just undo those dots. And so we think that's about where the intercept is. So then sketching the graph, or the final, the ordinate graph, there's still a few unknowns. Okay, so if I just grab my, we'll go with black, yellow, we'll go with yellow. If I sketch it, now the graph is going to increase. Does it go above there and come down, or is it go above and then come down to the blue? We're not too sure where that turning point is, and we can't know. But what we do instead is we give it that little curvy, nice little trig feel about it, and go through the points that we know. Okay, and so we've got that sort of nice curvy circular function flow about it, where we end up at 2 pi, okay? So it may not be perfect, but it's going to encapsulate all the key features, all right? If we go to the next one now, obviously we've got an inverted parabola and a truncus, it looks like. There's not a lot here we can tell. All I can really see is that -1.5 and 1.5. Again, the corresponding y values look like they're equal in size, and so when we add them together we'll get 0. So that's going to be my intercept. So what we do with these ones, we can see, if you like, and I'll go over it in green, from this part onwards, that's clearly the dominant graph, and the same on the other side. I'm getting bigger and bigger and bigger and bigger y values, yeah? And I'm just going to be subtracting a tiny little from the red graph, just a small negative value, which means my actual function, because the truncus is the dominant graph, it will act like that, okay? So it'll approach that truncus graph, but it'll never reach it, never touch it, because in fact we're subtracting a little bit from it each time. Because that truncus has an asymptote at x equal to 0, when we add the ordinates, the result's going to have an asymptote at x equal to 0 also. All right. So that's that section of the graph. If we think about the next section, I've got these small positive values, being added to big negative values, yeah? Which means my graph is going to be starting to act like whichever one's the biggest one, which is like the quadratic. So this time it's going to approach the quadratic. Never reach it because we're adding a value to it each time, but it'll certainly approach it. So if you want to have a look at I guess a definitive answer of it, if we have a look at the graph, it's probably something like 1x squared plus maybe minus a half x squared, is it? It goes through the point, maybe not quite. Anyway, but that'll give you a good idea of what it looks like. All right? Okay.